All right, hello everyone, this is Mr. Cruz. I'm going to help you with some problems that you're going to find in lesson 4.8, inverse trig integration. Well, the first thing we have here is this function to integrate, and it looks kind of complicated, but there's a rule that looks very similar, and the rule is if you have du over the square root of a squared minus u squared, it's equal to the arc sine function. That should be familiar with your derivative rule. So our job is going to be to turn this into this exact same thing over here, but notice it has an a term and a u term, so we're going to have to do a substitution and u substitution. Well, right off the bat, I know I need this 16 to be a squared, so I can let a squared equal 16. And I need u squared to be all of this, so u squared is equal to 3x squared. All right, so now that we have that, a couple things we're always going to do is we're going to take the square root of this. So this is a is equal to 4, and the square root of this is u is equal to root 3x. And I know I'm always going to take this down, so let's take the derivative here. The derivative here would just be the radical. And if I look over here, I just have a dx up here. So when I move this dx over here, I'm also going to move this root over to this side. So now I have these 1, 2, 3, 4, 5, 6 different lines, and I bet out of these 6 different lines I can make it match that and do my work. So ready? Integral, fraction, square root, not 16 but a squared, minus not 3x squared but u squared, not dx but du, with this constant out there. And now if you look at that, that exactly matches this formula over here. So now I can do my integration. My integration is, well, don't ever forget about that constant, times arc sine. And again, arc sine can be written like that, of the u term, which is right there, root 3x divided by the a term, which is right there, for, don't forget, plus c. All right, and that's how we integrate that function. Again, it involves u substitution and a substitution. And take the square root, finish this out to split up the du and the dx, and you'll have all the pieces you need. And then just start plugging in the pieces, and be careful over here, you're using a squared, which is 16, but in the formula they're only using a. So that's why you have to go back and forth between what parts do you use. I used all of these. I used these 4, and I used all five of those 1, 2, 3, 4, 5 substitutions. All right, on problem B. Same deal. Looks a little bit complicated until I realized that it matches this inverse tangent integral exactly. I think I can turn that into this. Well, first off, I need an a squared, so I need this to be a squared. So a squared would be 4, and a would be 2. Just take the square root. We're going to leave it positive. And I need all of this, which is u squared to the 25x squared. That's 5x. And again, I know from a lot of experience with u substitution, I need to get rid of a dx, and dx comes in right there, so that's 5. I only have a dx up here and a 3, so it doesn't match, so I'm going to pull this 5 over here and put the dx over there. Now when I rewrite this, step 1, pull the constant out front. The dx is a du with a 1/5, so I'll put the du there, and I'll just put the 1/5 out in front. 4 is a squared, plus, and all of this is u squared. So now it exactly matches this right here. All right, once I have that, just go through my steps. Don't forget about the constant, 3/15. Look at this, it has a 1 over a, so 1 over 2. Be careful that you don't use a squared, you use the 2. Inverse tangent of the u function, well, u is just that right there, 5x divided by the a function, which is just that, plus c. And there you have it. The only thing you should do is this coefficient should be 3/10 out front. We can multiply those fractions. All right, this should get you through a lot of the problems in this unit. The key is set up an a squared and a u squared and use that to get to this function over here.